demonstrate the use of an external interrupt to toggle an LED on and off. So let's see how this program works. So before going into the program, first let's know what is an interrupt. So how the interrupt should be, how the interrupt is occurred on the microcontroller, and how it should be served on the microcontroller. So all those things we shall know before getting into the program. So the main purpose of a microcontroller is to accept input from the input devices and accordingly drive the output based on the input given. Hence, there will be several devices connected to the microcontroller at a time. Also, there are many internal components in a microcontrollers like timers, counters, and other peripheral devices, etc., that require attention of the processor. Since all the devices can't obtain the attention of the processor at all times, the concept of interrupts come into picture. So basically, so an interrupt, as the name suggests, interrupts the microcontroller from whatever it is doing and draws its attention to perform a special task. Interrupt caused by an external source such as external switch, or it can be from sensors or monitoring devices. It can be anything. So from these external sources, if the interrupts are occurred, then that interrupt is called as external interrupt. So these interrupts are special events that require immediate attention, and this interrupt, so this should be served by the processor by taking into immediate consideration. An interrupt can be configured to be set off by a variety of triggers. Coming to the procedure of the interrupt. So assume that the microcontroller process the instructions in the normal flow. So first, in the program flow, so assume that instruction was one is being executed, after that instruction 2, after that instruction 3. After that, when instruction 4 is being executed, assume that if interrupt occurs from any external source, so if interrupt occurs from any external source, then that need to be served first by stopping the normal execution flow. So the normal execution flow will be stopped, and directly the program execution flow will go to the interrupt service routine. So the interrupt service routine will executes all the interrupts which is occurred at the normal execution flow. So later, all the interrupts will be executed. After executing all the interrupts, either it can be a single interrupt, or it can be two interrupts, or it can be a number of interrupts. After executing or after serving all the interrupts, then again the normal flow of the instruction execution will start from instruction 5, and later instruction 6, and later instruction 7, and later instruction 8. So this is how the interrupt should be this is how the interrupt should be handled in the interrupt service routine. So when the interrupt occurred, so the normal execution flow will stops. Then the program flow directly go to the interrupt service routine to execute all the interrupt which are occurred, and after servicing those interrupts, then the normal execution flow continues. So this is how the procedure of the interrupt happens in the microcontroller. Okay, so before going into the exact program, first we should know what is an interrupt, or IRQ. So IRQ stands for interrupt request. So in the event of an interrupt, the source of the interrupt, either it may be a timer or it may be a counter, it can be anything. So that sends a special request to the processor called interrupt request in order to run a special piece of code. So when the interrupt occurs, so the interrupt request will be sent to the processor to take an immediate attention to serve those interrupts. The special code or function is called as the interrupt service routine. So the interrupt service routine is a special code where all the interrupts are being handled. From the above figure, so from the previous figure which we have discussed, the CPU executes its normal set of codes until an IRQ occurs. So here in this figure, you can see that the IRQ occurs or the interrupt occurs after instruction 4, and the program flow directly go to the interrupt service routine to execute all the interrupts. When the interrupt request signal is received, the CPU stops executing the regular code or a normal code and starts executing the interrupt service routine. Once the execution of the ISR interrupt service routine is completed by the CPU, again it returns back to the normal execution of the normal code. So this is what the interrupt request means. So then another concept we have, so we should know this concept, that is vector interrupt control. So again, it is the main concept which comes under external interrupts. So we should know this vector interrupt. Let's see what is vector interrupt control. So in short form, we can call that as VIC. VIC stands for vector interrupt control. So basically, it handles the interrupt in LPC2148 series of microcontroller. It can take up to 32 interrupt requests at a single time. In LPC2148, the vector interrupt control take up to 32 interrupt requests. So the interrupts in LPC2148 microcontroller are categorized as fast interrupt request, vector interrupt request, and non-vector interrupt request. So basically, it has been categorized into three types. One is fast interrupt request, another one is vector interrupt request, another one is non-vector interrupt request. So all the interrupts in LPC2148 have a programmable settings, that is the priorities of the interrupts can be dynamically set. So user can dynamically set the priorities of the interrupts priorities for the interrupts to execute. So of the three categories, the FIQ, so that is nothing but the fast interrupt request have the highest priority. Vector IRQ requests have the medium priority, and the third one is non-vector IRQ. So that request have the least priority when compared to all the other three. So out of the possible 32 interrupt requests, so as I told, the VIC vector interrupt control can handles up to 32 interrupt requests. In that, 16 interrupt requests can be defined as vector interrupt request. In the 16 vector interrupt slots, slot 0 has the highest priority, while slot 16 has the least priority. So in this program, in the fourth program, we will be concentrating we mainly concentrate on the vector interrupt controller or vector interrupt request. So how many vector interrupt in request can be handled in the microcontroller or in the LPC2148 microcontroller until there can be up to 16 interrupts requests can be handled. So in that, in the 16 vector interrupt request slots, slot 0 has the highest priority, while the slot 16 or the slot number 15, so n minus 1, right? So 15 has the least priority. So this is all about the vector interrupt controller. So coming to the interrupt slot, as I told, up to 16 interrupts can be handled in up to 16 slots will be up to 16 interrupt slots can be handled in vector interrupt controller. You can see, so the here it starts from 0 to 10. After that, it starts from 11 to 22. So here you can see EINT1. So EINT1 is an external interrupt one which we are using in our fourth program. So in our fourth program, we are making use of this external interrupt one, so which is associated with the bit number 15. So which means that the external interrupt one is associated with the bit number 15 or slot number 15. So you should keep in mind that, so this slot number or this bit number 15 will be used in throughout the program. So external interrupt one, so we are executing this interrupt. So we are executing this interrupt in our fourth program. So here external interrupt is associated with the 15th bit of the microcontroller, 15th slot of the microcontroller. Next, so coming to the various addressing modes or various resistors which we are using in our fourth program. So the first resistor which we are using is VIC VCT8DDR0. So which is nothing but VIC stands for vector interrupt controller vector address 0. So as I told, so there are 16 interrupts that can be handled. So starting from 0th starting from 0th interrupt to the 15th interrupt, so a different address will be allocated uh, for each and every interrupts. So here we mainly concentrate, or we are mainly concentrate on the address 0. So that is nothing but VIC vector address 0. So let's see what is this vector address 0 resistor. So vector address 0 resistor, so that ranges from 0 to 15. It will hold the addresses of the interrupt service routine. Basically, it is mainly used to hold the address of the interrupt service routine for the 16 vector interrupt request slots. Okay, so another resistor which we are using is VIC vector control 0. So again, vector control 0 resistor. So vector control resistors from 0 to 15. Again, we have, as I told, there are 16 interrupts that can be handled in vector interrupt controller. So or vector interrupt request. So here again we have 16 different vector controllers. So vector controller. So vector controller, it ranges from 0 to 15. So vector control registers 0 to 15. Each control one of the 16 vector interrupt request slots. So again, slot 0 has the highest priority and the slot 15 has the lowest priority. So here you can see this instruction or this statement we'll be using in our program. So what is that? So VIC vector control 0. So here what we are doing is we are just assigning the external interrupt slot to the vector interrupt controller instruction or the register. So here you can see 0x20 or 15. 15 is the slot number which I've said earlier. So in the previous slide, so 15 is the slot number where external interrupt 1 is associated. So this should be controlled to handle the external interrupt. So that's why I have written 0x20. Here 0x20 will enable the interrupt request. That is nothing but 15th slot in the microcontroller to execute the external interrupt 1. Okay. So another resistor which we are using is VIC interrupt enable. So VIC stands for again vector interrupt controller interrupt enable. So this resistor is used to interrupt enable resistor. It is nothing but interrupt the or enable the interrupt resistor. So again, 15th pin should be enabled to execute EINT1. So as you people know, so the 32-bit instruction it can handle. So it ranges from 0 to 31. So here we have 15th bit. So here you can see across 15 bit have written 1. So across 15 bit have written 1, and this binary format should be converted to hexadecimal format because the microcontroller works on the hexadecimal format only. So here you can see for vector interrupt enable, for vector interrupt control interrupt enable, I am assigning the register configuration as 0x followed by 4 zeros 8 000. So this what the register configuration for the vector interrupt controller interrupt enable. So this will basically enable the interrupt register. So again, interrupt register is associated with external interrupt 1 is associated with 15th pin. So that's why I have written 1 across the 15th pin. So the final register configuration after converting from the binary to the hexadecimal is 0x followed by 4 zeros 8 000. So this is what the vector interrupt controller interrupt enable means. Next, we have another concept that is nothing but a register configuration to activate LED when interrupt occurs. Basically, so when the interrupt occurs, the LED will glows on. So after servicing the interrupt, after servicing the interrupt, the LED will close off. So this will be happens from a mechanism called push button mechanism. So we'll be using push button mechanism to occur the interrupt or basically to execute the interrupt on the ongoing process of the microcontroller. So push button. So when you push the button, so it is a push mechanism button. Basically, when you push or when you press the button and when you release it, so the light will glows on the LED. Again, when you press the button or when you push the button and when you release it, the light will get off. So that's what the interrupt mechanisms in the fourth program. So basically, so we want to know that the external interrupt is being executed, right? So basically, if you want to know that it is being executed, then we can see through the LED. So which for that's the reason we are integrating LED mechanism to our program. So when the external interrupt is being executing, so the LED will get on after executing the external interrupt. When we press the push button again, the LED will get off. So that's what the mechanism is. So here we are integrating LED into our program. So again, this the LED is configured in port 1 of the microcontroller, port 1, 25th pin. So LED is configured to the microcontroller in port 1 of the microcontroller. where in the port 1 25th pin. So 25th pin of the port 1 is configured with LED, so that should be enabled. So then only the LED will gets on, or the LED will get off based on the interrupt occurs. Okay, so if we are integrating LED, so then we need to use the resistor configuration. So here you can see, as I told, LED is associated with the port 1 25th pin. Again, in port 1 there are 32 bits, so ranging from 0 to 31. So here you can see across the 25th bit I have written 1, and across all other bits I have written 0. So if we convert this binary representation to the hexadecimal representation, 0010 is nothing but 2 in the hexadecimal. So after converting each and every bits to the hexadecimal, the final resistor configuration is 0x followed by 0260. So this is what the resistor configuration to enable the, or to set the direction for the LED. So LED is, again I'm telling, LED is associated with port 1 of the microcontroller with the 25th pin. Next, another resistor which we are using is external mode. Okay, so external mode is another resistor instruction which we are using in the fourth program. So basically, the external interrupt mode resistor controls whether each pin is edge or level sensitive. Okay, so again, so as I told here, in external interrupt, basically we are using push down button. So when you push or when you release the, when you push and when you release the button, so either it should be an level triggered or it should be a edge trigger. It can be anything. So if it wants to be a level triggered, then 0x00 should be represented in the program, or if it wants to an edge trigger, then 0x01 should be assigned to the external interrupt mode. Okay, so there can be two modes of operations. One is level triggered, another one is edge triggered. Okay, so if you want to execute in a level triggered, so if you want to execute the interrupt in level triggered, then you should assign 0x00 for the external interrupt mode. Or if you want to execute the interrupt in edge triggered, then you need to assign 0x01 to the external interrupt mode. So this is what the external interrupt mode. So either it can be an, the mode can be either it can be a level triggered or it can be an edge triggered. In our programming we are using edge trigger, so that's why I'm assigning 0x01 to the external mode, the external interrupt mode resistor. Another main which another important resistor which we are using in our program is external polarity. So actually the external interrupt polarity resistor controls which level or edge on each pin will cause an interrupt. So if we select a level triggered, then either it can be a low level or it can be a high level. Or if we choose edge trigger, then it can be a falling edge or it can be a rising edge. Okay, so if we select level triggered as the external interrupt mode, then external polarity should be, so it can be 0x00 for low level, 0x01 for high level. If we select edge triggered as the external interrupt mode, then external interrupt polarity will be 0x00 for falling edge and 0x01 for the rising edge. So here I'm using, in the program I'm using edge triggered as the external interrupt mode, and for that edge trigger I'm using falling edge. So that's why I'm assigning external polarity or external POLAR is equal to 0x00, which means that the external mode is an edge triggered with falling edge. So that's what the instruction means. So basically these external interrupt mode and external interrupt polarity, these two resistors again I'm using the program. So hope you have understood this. Next, let's see another important concept which is associated with this program is pin select resistor. So again we are using this pin select resistor basically. So why we need to select the pin in this, why we need to select the pin in the microcontroller to execute this program? So basically, so here as I told, there are n number of functions that are associated for each and every pins on the microcontroller. So as you people know, so there are 4 pins on the microcontroller, 16 pins on each side. So which means that there are 4 sides on the microcontroller. So for each and every pins, one or more functions can be associated. Here, as we are executing or as we are illustrating the external interrupt one, this function should be selected. So this function should be selected. So that's why we need pin select resistor. So that corresponding function will be selected by the pin select resistor. Let's see how the function will be selected by using pin select resistor. So before that, let's see some theoretical concepts about pin select resistor. So most of the pins on LPC2148 are multifunctional. Every pin can be used to perform one of the assigned function to it, depend on the setting of the pin select resistor of the specific port to which the pin belongs. So as I told, there can be a single function which is associated for the pin, or it can be a maximum of 4 functions that can be associated for the pin. And at a time, only one function can be executed through that pin. Okay, all the 4 functions cannot be executed at a time, only one function can be executed, and that function should be selected by the pin select resistor. So there are total 3 pin select resistor which are available in LPC2148 microcontroller in order to control the functions of the pins in the respective ports. So here the classification as given below. So as I told, there are 3 pin select resistor. One is pin select 0, second one is pin select 1, and the third one is a pin select 2. So as we discussed, as you people know, so there are 64 pins. In that 64 pins, it has been divided into 2 ports, port 0 and port 1. First 32 pins will comes under port 0, and the next 32 pins will comes under port 1. So in that as I told, the first 32 pins, as I told, the first 32 pins which comes under port 0, that is again divided into 2 pin select. So the first 16 pins are associated with pin select 0. Basically, it is used to control functions of port 0.02, port 0.15, 16 pin. The first 16 pins in port 0. Next, pin select 1. So the next resistor which controls the functions of port 0 16th pin to port 0 31st pin. So now we have completed the first 32 pins. So as I told, so there are 64 pins on the microcontroller. In that 64, the first 32 pins comes under port 0, and the next 32 pins comes under port 1. Okay, so in port 0, again the pin select resistor is classified into 2. So in the pin select 0 constitutes of port 0.02, port 0.15. Pin select 1 controls the functions of port 0.16, 16th pin to port 0.31, 31st pin. So again we have port 1 31 pins, right? So in port 1 we have other 32 pins. In that first 16 pins that cannot be used, or that cannot be used for the programming. Further, the next 16 pins, can be used for the programming, and that for to control those pins, we have pin select 2. So that is the basically pin select 2 control functions the port 1 with the 16 pin to port 1 of the 31st pin, which means that the first 16 pins, that is nothing but port 1, 0th pin to port 1, 15 pins. So those 15 or 16 pins cannot be used for the um, general input output functions. So with the next 16 pins on the port 1 that can be used, and to control those pins we have pin select 2, basically that controls the function of port 1 16 to port 1 31, 31st pin. So here in our program we are mainly concentrating on this pin select 0. We will use this pin select 0. So I will let you know why we need to use this pin select 0 later. So here you can see the LPC2148 microcontroller. So here you can see this microcontroller. So this microcontroller has a 64 pins range, starting from 1 to 64. So we have 64 pins. You can see here all the 16. So on each side there are 16 pins. Okay, on each side there are 16 pins. So in that you can see here on the 26th pin. So here in the below you can see that on the 26th pin we have a function called EINT1. So EINT1 is nothing but external interrupt 1. So we are making use of this external interrupt 1 in our programming. So this is the fourth function in 26 pin. So what are the other 4 functions we have? Port 0.3. So port 0 point third pin, which is nothing but general purpose input output. Another one is SDA 0. Another one is MAT 0.0, and the fourth one is EINT1. So we are making use of this EINT1 external interrupt 1 function. So this is the fourth function which is associated with the 26th pin of the LPC2148 microcontroller. So let's see how this function will be selected. So as you know, so as I said, so 26th pin has a four function. Function one is a port 0.3, so that is nothing but GPIO pin, general purpose input output pin. So general purpose digital input or output pin. Then function two SDA not, it is nothing but inter integrated circuit data input or output. And the function three is a MAT 0.0, that is nothing but a match output for timer 0. Then the function 4 is EINT1. So this is the function which we are making use of it in our program. So the function 4 is EINT1, that is nothing but external interrupt one input. So here you can see that 00 should be represented to execute function 1, 01 should be execute 01 should be represented to execute function 2. So 10 should be represented to execute function 3, and 11 should be represented to execute the function 4, which is associated with the 26th pin of the microcontroller. Okay, as I'm using this EINT1, so that is nothing but external interrupt 1, so I need to represent 11. So where I need to represent is 11, so let's see that later. So in this you can see so how this 11 should be represented. So as you know, pin select resistor configuration, so pin select 0 which we are using here. So again, why we are using pin select 0? So we have other two resistors, right? Pin select 1 and pin select 2. So we are not using that. We are using only pin select 0. Why means EINT1. So that is nothing but external interrupt 1 is associated with the port 0 third pin. Port 0.03 means port 0 point third pin. So in this general input output pin, the EINT function 1 EINT1 is associated. So as you can see, it is of port 0. So port 0 third pin will comes under pin select 0. So as we have discussed here, so here you can see pin select 0 it ranges from port 0.0 to port 0.15. In our program, the external interrupt 1 is associated with port 0.03, which is nothing but port 0 third pin, that comes under pin select 0. So that's why I'm writing the resistor configuration for pin select 0. That's why I'm selecting this pin select 0, which basically controls the functions of port 0.0 to port 0.15, which means that total of 16 ports that are associated for the pin select 0 resistor. Okay, how many ports are associated for pin select 0 resistor and the killer? So it will be 16 ports. So here you can see the 16 ports ranges from port 0.0 to port 0.15. So these are the 16 ports that are associated, and these 16 ports we will make use of the 32 bits that are available in the microcontroller. You can see here the bits ranges from 0 to 31. So total 32 bits. Okay. So here each and every ports acquires 2 bits. Okay. Port 0.0 acquires 2 bits. Port 0.1 will acquires 2 bits. Likewise, port 0.10 that will acquires 2 bits. Again, port 015 that will acquires 2 bits. So as I told, port 013 is associated with external interrupt 1. So here you can see port 0.3. So port 0.3, which is nothing but the third pin of the port 0. So here 7th and 6th bit is 7th and 6th bit. So here we have two bits or two pins, that is nothing but 7 or 6. So here I have represented double one. So here I have represented double one across the 6th bit and as well as the 7th bit. Why I'm writing double one here until the rest? So you can see here double one is used to activate, or double one is used to make use of the function 4. So here you can see EINT1. So I'm making use of this function. This function comes under function 4. To make use of this function, I need to write a double one. So you can see in the pin configuration. So across the 6th and 7th bit comes under port 0 third pin. Port 0 third pin is associated with external interrupt 1. So that's why I have written double one across port 0 third pin. So under port 0 third pin, there are 2 bits, 7th bit and 6th bit. So I have written 2 ones like this. So if we convert this double one double zero, if we convert this double one double zero, then you may get 12. So 12 in hexadecimal will be called as C. So double one double zero, if you convert this double one double zero to the hexadecimal, then you will get C. And we have in other ports are zeros. So I have represented zeros across other ports. So the final resistor configuration to select pin select is 0x followed by 6 zeros, then C0. So this is what the final resistor configuration. So EINT1. So external interrupt 1 is the fourth function. So double one need to be mentioned across port 0 third pin. So that's why I've written double one. So C, so double one double zero. So double one double zero is nothing but 12 in decimal. So if you convert that to hexadecimal, then it will be represented as C. Okay, so this is how the pin select function or the pin select resistor works on the microcontroller. Hope you have understood this pin select. So it is very important. So I'll be using this resistor configuration, pin select resistor configuration on the program. So if you have any doubts, you can WhatsApp me later. So next concept is configuring the interrupts in LPC2148. How the interrupts are, I will be explaining how the interrupts are configured in LPC2148 microcontroller. So as of now that we have seen the list and functionalities of different resistors that are associated with the vector interrupt controller. So we have seen a vector interrupt control interrupt controller. Then we have seen address vector interrupt address. So many and vector interrupt controller enable. So all these things we have discussed. So basically these are associated with vector interrupt controller VIC interrupt request. So now we will see how to configure interrupts and define the respective interrupt service routines to execute the interrupts on the microcontroller. For that, first we will see how to properly define the interrupt service routine function so that the compiler understands that it is in ISR but not a regular function. Okay, so basically, so if we are executing the interrupt on the interrupt service routine, then it is called as the function, so which is nothing but the user defined function. So obviously, so there is a lot of difference between an user defined function and an interrupt service routine or interrupt function. So the compiler will get to know. So the compiler, there is a differentiate between there is a lot of difference between user defined function as well as the what interrupt service routine function. So that the compiler understand that it is an ISR but not a regular function. So let's see how the compiler will identify that it is an ISR function. So in Keel IDE, we can define the ISR in two ways, and in both the cases, we need to use the keyword and double underscore IRQ. So double underscore IRQ is the keyword. Basically, it is used to define the interrupt service routine, which means that if you represent double underscore IRQ to any of the user defined function, then the compiler will treat that function as the interrupt service routine and immediate attention will be given. So immediate attention will be given to that user defined function. So as I told, there are two ways. The first way, let's see the first way. The first way to define ISR. So here you can see double underscore IRQ. So there is a keyword which is used to for the function user ISR, which is an user defined function, and the return type is void. So and the parameter is also void. So here you can see this is a user defined function with double underscore IRQ, which means that it is nothing but the interrupt service routine function. The compiler will treat this as an interrupt service ISR function and not a user defined function. So for that we are writing a keyword called as double underscore IRQ. So again, on the second way, so on the following is the way to define the ISR. So this is the second way. So here what you have done until so we have used the keyword at the end of the user defined function. That's it. In the first way, I've used the keyword at the starting of the user defined function. In the second way, I have defined double underscore IRQ as the keyword at the end of the user defined function. So both the ways is works fine. So you can define the interrupt service routine or interrupt request in both the ways. You can mention the keyword at the beginning, or also you can mention the keyword at the last. So the body of the instruction will comes between the pair of flower braces. So this is how the ISR function works on the microcontroller. Okay, so here you can see the LPC2148 microcontroller board. So here this is external interrupt and this is external interrupt one, EXTINT1, EINT1. So here you can see EINT1 and there is a push down button. You can see here push down button. So when you push this button again, begin based on the mechanism, it will come back. Okay, when you push this button, the light will get on. When you push the button again, the light will get off. So that's what the external interrupt works. So if it is in normal mode, so the light will either be in high level or low level. So high level and again it will be in on mode, low level and it will be in off mode. Okay, so if you are interrupt, so if you want to want to make an interrupt to that light, then obviously the interrupt can be done through this push down button, which means that if the light is in on mode, when the interrupt occurs, it will go to off mode to service the interrupt. Okay, so again, after servicing the interrupt, when you click on the push down button again, so the previous state, in the previous state, the light will be in on mode, right? So when you click on the push button again, now the light will glows off, the light will gets off, and the process will executing in the normal process, normal execution. So that's what the external interrupt means. So you can see the execution of this program in the another video. So now, so let's go into the program. So as we have discussed the various resistors which we are using in this program, so I think you know what are the resistors which we are using. So, and also, you know, also we have discussed the resistor configuration that is associated for all the resistor. So let's see the program. So in this program, I'm using an header file called LPC214x.h. So here x can be 2, 4, or 8. So in our lab we are using LPC2148. So this is nothing but the header file. All the predefined functions which are associated, all the IODR, IO set, pin select, all these registers are configured in LPC214x.h header file. So that's why I'm linking that header file in the starting of the program. Then after that, I'm declaring the IRQ function. So that is the return type is void, and the function name is external interrupt one, EXTINT1 underscore ISR, and we have one parameters that is nothing but void. The type of the parameter is void. Then double underscore IRQ. It is a keyword which basically the compiler will get to know that it is not a normal user defined function. It is an interrupt request function. So that's why I've represented the keyword at the last. Again, you can represent this keyword at the beginning also, no problem in that. So while declaration of this, the declaration of ISR, so that's why I'm closing with a semicolon. Okay, next I'm declaring two variables on the global declaration section. So the type of that is unsigned character. So the two variables is int flag and flag. If int flag is equal to, so if int flag is equal to 0x01, then interrupts are being occurred. Okay, if int flag is equal to 0x00, then no interrupts are being occurred. So that's the purpose I'm using int flag. Another one is a flag. If a flag is 0, if it is a flag 0, then the light will go off. If flag is equal to 1, the light will go on. So let's see how this flag will be associated with a 0 or 1, and how the int flag is will be given as a 0x00 or 0x01 in the program later. So then main function. So the return type of the main function is void. It can be an int type also. It can be an int or it can be void. Anything can be fine. So next, and under the main function, the first instruction or the first register which I'm using is IODIR1. So IODIR is nothing but input output DIR. So input output direction. Here I'm setting the direction of the pin. So what pin I'm setting for what pin should be selected. So as we have discussed, or is equal to is, it is nothing but the output, which means that when you give the input through the push down button, the output will be enabled from the LED. So that's why output should be given, output configuration should be given here. So here LEDs LED, what's the pin number for the LED, and tell the pin port 1 25th pin. So port 1 25th pin is associated for the LED. So that's the output that's the output that is obtained from this program. So that's why I've written this configuration where which we have already discussed. I have written 1 across the 25th pin. So when converting those binary data to the hexadecimal, so we get this 0x followed by 02 followed by 6 zeros. So we have discussed in the previous slides about this register configuration. Go through that. Then the next one is IO set 1. I'm setting that pin to high state. So that's why I'm using IO set 1 instruction. So again, why we need to use one other, so we can also use IODIR 0 and IO set 0, right? But why we need to use one here until the rest? So because 25th pin of the LED is in port 1. So port 1, so we are making use of the port 1. So that's why I'm representing one across the IODIR and one across the IO set. Okay, so that's why I've written one across IODIR and one across IO set resistors. Next resistor which we have discussed is the pin select resistor. So as I told, there are three pin select resistor. One is pin select 0, pin select 1, and pin select 2. In our program, we are making use of this pin select 0 because port 0 third pin is associated with external interrupt 1. So that's why I'm using pin select 0. And also we have discussed the resistor configuration 0x followed by 6 zeros C0. So this is the resistor configuration that need to be given to select the fourth function, that is nothing but external interrupt 1. So to select that fourth function, so this is the resistor configuration. Again, we have discussed this in the previous slides. Go through that. After that, external mode. So external mode is equal to 0x01. So it is nothing but it is an edge triggered. Okay, if you want to execute this in level triggered, then you can write it as 0x00, no problem in that. So you can mention anything. So here external interrupt mode is 0x01. It is nothing but edge triggered. Then external polarity, external interrupt polarity is 0x00. 0x00 is given for falling edge. 0x01 will be given for rising edge. Again, it can be anything. So here I mentioned 0x00. 0x00 given for falling edge, and 0x01 for the external interrupt mode will be given for the edge triggered. After that, we have discussed another resistor called vector interrupt control vector address 0. So for this, what I'm doing until there, I'm assigning the user defined function. Okay, I'm assigning the ENT0 ISR function to here. So when this function is assigned, it will directly go to the uh, here. So it will directly go to the user defined function here. So here you can see extint1 underscore ISR. So this is the function which I am assigning to the vector interrupt control vector address 0, which means that interrupt service routine address is that address interrupt service routine address is I'm assigning that to the VIC vector address 0 resistor. So when we call this function, so when we call this function, it will directly go to this function. It is a user defined function. You can see with a return type, it's void extint1 underscore ISR double underscore IRQ, which means that it is not a normal function. It is a interrupt request function. So whenever there is a low edge on ENT0, so external interrupt will be set to E0x followed by 02. So basically, if there are any previous interrupts, so that should be cleared. So for that, we have external interrupt is equal to 0x02. This code will clear the interrupt. Okay, will clear the interrupt. After that, interrupt will be serviced. So then in interrupt flag. So this is a global declaration flag which I have explained earlier. So interrupt flag is equal to 0x01. So which means that interrupts are being handled. If interrupt flag is equal to 0x00, then there are no interrupts. If interrupt flag is equal to 0x01, so there is an interrupt and that should be occurred, or an immediate attention should be given to that interrupt. So this will be done inside the external interrupt 1 ISR function. Then vector address is equal to 0. So after executing all the interrupts in the interrupt service routine, the address will be assigned 0, so that no interrupt should be so that no interrupts are there in the address to execute. So that's why interrupt address vector interrupt controller vector address is equal to 0 is mentioned. So which means that acknowledge interrupt. So after that, so again it will go to the calling function. So here you can see vector address 0 is, if vector address 0 is equal to 0, then there are no interrupt. So if it is not 0, then interrupt is there. That should be serviced in the interrupt service routine, and that will handles in the user defined function, that is nothing but external interrupt 1 ISR. So another function which we have, or another resistor which we have discussed until, the VIC vector control 0. So again VIC stands for vector interrupt control vector control 0. So which is an highest priority for this control 0. This resistor will be have highest priority when compared to vector control 15th controller. So VIC vector controller 0 has the highest priority, basically 0x20 of 15th. So again, the 15th slot in the interrupt slot, in the overall interrupt slot, the 15th slot is given for the external interrupt 1. So if we are using external interrupt 1, then 15th slot should be assigned to the vector interrupt controller. So it will assign the vector interrupt controller EINT1. EINT1 stands for external interrupt 1 to interrupt the with priority 0. So here you can see there is a 0 after vector control instruction, because 0th control has the highest priority when compared to 15th control. So another instruction which we have discussed is vector interrupt control interrupt enable. It will enable the interrupt. So as you people know, so EINT1 interrupt is associated with 15th pin, so which is nothing but 15th pin. So here you can see 15 for the control instruction. For the control register also I have assigned the 15th pin. Again, if we represent 15th pin across 1, if you represent 1 across the 15th pin, then the register configuration will be 0x followed by 4 zeros 8000. Again, we have discussed this in the others in the previous slides. Go through that. So if it is, so here in this instruction, what we are doing until just we are enabling the interrupt one, enabling the interrupt one interrupt. So after that, so while loops, so while of 1, so we don't have any condition, so infinite times the loop goes on executing. So if int flag is equal to 0x01, then interrupt is occurred. So if int flag is equal to 0x00, then interrupt has been serviced. So that's what the difference between int flag is equal to 0x01 and 0x00. So if it is true, andre int flag is equal to 0x01, it will go to the true part. So what is there in the true part? Again, another if condition is there. If a flag is equal to 0, if a flag is equal to 0, then the light should be go off, the light should be off. So that's why what I am doing is IO clear. So IO 1 clear. Again, this one can be written written after IO, and also this one can be written after clear. Okay, so like this. So here in this instruction I have written IO1 clear. So this is same as IO clear 1. So both are same. So again, here I've written IO1 set. So here I will write 1 at the end. So both are same. It can be anything. Okay, so IO clear 1 is equal to 0x followed by 0 to 6 zeros. And here what I'm doing is LED ಇದು what's the pin number for the LED ಅಂತ ಹೇಳಿದ್ರೆ, so port 1 25th pin. So that's why on the 25th pin I have written 1. So the resistor final resistor configuration is 0x02 followed by 6 zeros. So I'm setting the 25th pin to the low state, which means that LED will gets off. If it is in on state, the LED will gets off. So then flag will be initialized to 1. Okay, then flag will be initialized to 1 only when flag is equal to 0. Otherwise, if this condition is false, if a flag is not equal to 0 agidre, it will go to the else part. In else part we have another condition. If it is not equal to 0 obviously it should be equal to 1. If a flag is equal to 1, then what I'm doing is I'm setting the 25th pin to the high state. In that case, the LED will gets on. So in that case, LED will gets on. To set the pin to high state, I have a resistor configuration as IO set 1 is equal to, again, why we should write 1 until the 25th pin of the LED is associated with port 1. So that's why I need to write 1 across 1 at the end of the instruction. So is equal to 0x02 followed by 6 zeros, which means I am setting the 25th pin to the high state. Here 25th pin under port 1 is associated for the LED. So now LED will gets on. Okay, after LED gets on, again the flag variable is initialized to 0, and it will come out of the inner if. Then int flag is equal to 0x000, which means that the interrupts are being serviced after interrupts are being serviced. So again, if int flag occurs 0x01, again this process goes on. So like this. So whatever the statement which is there inside the infinite loop or while loop 1, so this will go on executing until and unless you switch off the microcontroller. So if you have not switched off the microcontroller, this process goes on, which means that when you press the or when you interrupt the microcontroller through the push down button, this process goes on executing. So that's what the program is. So we have discussed this user defined function. That is nothing but it is not basically it is a user defined function, but it is not an exactly user defined function. It is an interrupt request user defined function. Okay, it is an interrupt request user defined function. So that's why I have written the keyword as _IRQ. Then coming to the result, after dumping the code to the microcontroller, so when we press the interrupt switch, the LED will goes off, and again if we
and again if we press the same switch, the switch is nothing but push down button, which we have discussed in the explanation. Okay, switch and push down button both are same. So again when we press the switch, the LED will gets on, which indicates that interrupts are being servicing on the microcontroller. Okay, so hope you have understood this program. Let's see how to execute this program. So I will minimize this. So I will open Kill Microvision 4. So here it is available in the desktop. So double click on that. It takes some time to open. So after when it opens, so if there is any previous project, that should be closed. So here you can in the taskbar go to project and close project. Click on close project. So now new project should be created before creating the file. Okay, so let's see. I will create a new project now. Click on project, select new microvision project. Then it will ask the root folder. So I have created a root folder on the desktop as a prog. So this is the root folder. So here I will give the project name as external. Okay, so this is the project name. So when you want to give the project name, no need to give the extension. Okay, this file should not be with any extension. Then click on save. Don't give any extension. So after that, so there is a search bar here. You need to type LPC2148. Okay, so you need to type LPC2148. So select this LPC2148 and click on OK. So it will ask copy startup.s to project folder and add file to project. Click on S. To execute all the part A program, you need to click on No. To execute all the part A programs, you need to click on S. We need startup.s because all the library files, all the header files are declared in startup.s file. Okay, so now we have successfully created the project. Now we need to create the file. So go to file, click on new. So then save this file, go to file again, save as, give a name. So I will give the name as ext internal. Okay, ext internal with an extension .c because I'm writing a C program to execute this. So that's why the file name should be .c. So ext internal .c. I'm naming this file. It can be anything, but the file name, the file extension should be .c. Click on save. Okay. After this, so type the program here. So have typed the program. Then you need to link this file to the project. So I will show how to link this file to the project. So again, here in the left side panel, there is a window called project window. So go there. So there is an option called target one. Click on the plus symbol. So then there is a source group one. So select that source group one, right click, select add existing files to group source group one. Okay, select this. Then so here you can see external ext internal. So this is what the file which I have created. I will click next. You need to click on add, then close. So if you click on this plus symbol under source group one, you can see there are two files. One is startup.s, another one is external dot c, external dot c. So here you can see, so here you can see this program, this file has been linked to the project file. Next we need to do some changes, or we need to do some settings. So select the target one under the project window. Okay, select this target one, right click, select options for target one. So here under output, you need to enable create hex file. Okay, so you need to enable create hex file and you need to give the name as ext interrupt. So create an hex file name. So no need to give the extension, just give a name. So the name can be anything. So here I have given ext interrupt. Okay, then select this linker. Under linker there is an option called use memory layout from target dialog. So you need to check on that. Then click on OK. After this, you need to rebuild the program. You need to compile the program. So I will select this rebuild option. So here the header files will be linked first. After that, the program will be compiled. After that, X file will be created. So all these things will happen in a rebuild function. I will click on this rebuild. Yeah. So now the program has been compiled with the 0 errors, and also X file has been created. Okay. Now what we need to do until that this X file need to be dumped to the microcontroller. So now you need to connect the microcontroller to the CPU, and also you need to connect the power cable to the microcontroller. After doing that, then you need to open Flash Magic. Okay. So you need to open Flash Magic application. So here you need to dump the hex file which you have created. Okay, so here you can see hex file. So click on this browse button. So the hex file which we have created is external interrupt.hex. So select this hex file, then click on open. So when you click on the start button, so the hex file, external interrupt hex file, will be dumped to the microcontroller.
Go to browse, then go to your root project folder. So here external 1.hex, so this is the hex file we need to dump to the microcontroller. Select this hex file, then click on open. Okay, so after that you can click on the start button. So now coming to the microcontroller, so here I have connected one pin to the CPU, and another the power cable. I have connected the 5 volt DC power supply power cable here. So this is the interrupt. So this is the external interrupt. This is the external interrupt in the microcontroller. So here, so you can see here. So there are two interrupts. One is external interrupt 1. Another one is external interrupt 0. So here we are using external interrupt 1. So there are two pins here. So this is called as the jumper. So we need to short these two pins. Okay. By using this jumper, we need to short these two pins. So I'll be connecting the jumper here now. So we have a button here. So if you click on this now, the light will get switches off. Then if I click on the same button again, the light will get on.